Good morning, everyone. We are Team 29 and we are presenting to you our project for the Distributed Systems course. The project is called DISTRO Hack. It's basically a distributed systems based hackathon that we have thought about implementing for our project this time. I hope you guys like our presentation. We have a great team which comprise Kaiyu Wu, Minglei Chen, Zilin Liu, and myself Ashish Kaila. Our TA is Patrick Lazik. So what is a hackathon? A hackathon is an event in which computer programmers and others in the field of software development like graphic designers, interface designers and project managers collaborate intensively on a software related project. The idea is to build something cool and to do that as quickly as they can. A traditional hackathon usually takes place in a university campus or the campus of a software company hosting the event. The event has hackers from different places usually congregate at the same location and participate in the event, which lasts several hours. Our vision, on the other hand, is to take this experience provided by the hackathon and take it to a distributed level. Our application provides programmers a platform to compete with others in the coding competition as though they were physically present there. Each player will compete with others, hacking on different coding challenges, and during the competition, each player can see the other's status in the competition. To make the hackathon interesting and the overall experience more engaging, the hackathon would be based around a story. Each competition would be associated with a story and composed of several challenges. When coding, each programmer can see the current status of the other challengers and which problems they are working on and how many they have currently solved. Programmers have to work on the problems in a given order so that there is some kind of a fair outcome on who wins and who doesn't. There are loosely defined affinities, which mean the programmers can freely enter and leave the competition. In the following slides, we will go over the project architecture and the various distributed systems concepts that we will be using in this project. We will end the presentation with the discussion on the technical and distributed system challenges that we will face. The architecture consists of a client having a front end and a back end which communicate using JSON objects. Various clients communicate among each other using a form of distributed message passing to exchange state information and other game-related information. The front end uses Twitter Bootstrap to create a website-based interface that would be exposed to clients. The back end uses Django, which is a high-level Python-based web framework that encourages rapid development and clean pragmatic design. The message format between the front end and the back end would be JSON-like objects. Message invocation usually would include user answers or game-related state information that will be exchanged. We decided to use Go as the language that will be used to implement the message passing interface among clients. Go provides a simple and reliable mechanism to communicate among different nodes in a distributed system. The high-level architecture of our distributed system is very similar to Skype. It consists of a bunch of supernodes that exchange messages among each other and a bunch of ordinary nodes that are registered to the supernode. The idea is that the ordinary nodes communicate among each other and the supernode they are registered with, and the supernodes communicate among each other to reduce the overall message traffic. This way, all the state information is maintained in a hierarchical manner. The supernodes exchange information about the managed ordinary nodes. A peer-to-peer communication is used between each pair of supernodes to exchange this information. The information exchange could be either incremental or bulk-based. The supernodes are usually elected using a voting algorithm such as an invitation algorithm or another efficient algorithm. Ordinary nodes, on the other hand, are associated to a particular supernode and they exchange using a peer-to-peer mechanism, communicating among each other. Ordinary nodes sign up with the nearest supernode, typically reading the location of the supernodes from a DNS-like hosts file. Supernodes are used to balance the total number of clients per supernode in such a way that they create some kind of a dynamic load balance. Ordinary nodes are pretty fickle. They can enter and leave at any time. So in essence, a failure or the entrance or the leaving of an ordinary node is effectively the same. On the other hand, the failure of a supernode causes an invitation algorithm or some kind of an election algorithm to run so that a new supernode can be elected. There are several challenges that we will need to deal with. A couple of them are like failure recovery, load balancing, and how to maintain low latency among communication, especially with the large number of messages that are going to be exchanged. The project provides us a wide variety of areas where we can increase our expertise. The team has no working knowledge of JavaScript or Go and will require significant amounts of time to ramp up on these areas. Similarly, the team does not have any working knowledge of Django, which is to be used as the backend of our application in each node. We plan on using an agile software development methodology to help us keep track of the project milestones and the progress made by each member of the team. Over and above this, the design methodology used in the project will require us to think in a distributed and scalable design manner. We thank you for your time in hearing our presentation, and we would look forward to hearing your feedback on the same. Thank you.